First of all, we want to introduce Hugues Lefevre, my colleague from HEC, Glass Europe. I must also read the text a little bit because it's a lot of information which I did not know before, honestly. So he's the product manager for health, safety and security glass products at HEC Glass Europe. And for the recently, he's in charge for the new product range for low carbon glass as well. So this is the topic of his talk today. So yeah, enjoy the next 25 minutes and yeah, enjoy the afternoon session. Thank you.
Thanks a lot to be there. So we will start the afternoon with the holistic approach to produce low carbon float with less than 50% embodied carbon. I will speak to you about the glass industry and its effort to reduce the greenhouse gas emission. Also some practical proposition and our proposition to reduce the embedded carbon. Then I will give you the result of what we did. Also, very important to speak about the transformation product, because not only the float, we have to take care not only about the float, but also other transformed product. And finally, few conclusion. So let's start with the glass industry and the effort to reduce the greenhouse gas emission. Why we suddenly want to do this? Of course, there are a long time we speak about, but the objective to reduce the green gas emission are now very well defined and set. There are different legislation package at the level of the industrial sector, all topic together. So the carbon intensive industry have now to reduce their emission, and there is some cost about CO2, the cost of direct emission of CO2 have been defined at the European level. I think it was yesterday, there was already some presentation about this from Glass from Europe. Also at the construction level, there is more national legislation to limit the embodied carbon into the building materials. And it is also at the level of the European level, but today it is more the local legislation that are in advance. Of course, there are also the massive public concern about the climate change, plus all this regulation that really push the industry, especially the glass industry, to commit to a maximum carbon emission target. Typically, the glass industry commit on significant decrease, typically 30% reduction of CO2 emission for 2030. I say typically, but AGC commit on this, but not only, other company also. And the target is to achieve zero carbon or net zero by 2015. Also an important point, everybody push for this, everybody is agree on this, but it seems that the market is not yet ready to accept some quality decrease or downgrade of product and so on. So we suppose that the product, the glass we will deliver to the industry, by the industry have to be significantly the same. So just a very quick overview of different national legislation. The most in advance is the French one, RE 2020. So it's already in force since 1st of January 22. And by step of 2 years, it make mandatory to respect some maximum level of CO2 emission per square meter of building, build or renew. But you can see that Netherlands, Denmark, Finland, Sweden, different other countries are following. After this, there is also under preparation in Germany, in Belgium, and so on. But this is the most advanced. When we speak about reduction of CO2 by the glass industry, or here I take the example of AGC, we suppose the scope 1, the scope 2, and the scope 3. In the glass industry, each scope are quite important. You see the pie for AGC, but it's quite similar for each big glass maker. So the scope 3 is clearly all the energy we put in the furnace, but also the raw material decarbonisation. The scope 2 is the electricity consumption, and the scope 3, there is all the part in upstream that concern the raw material, extraction, transport, preparation of raw material, and the downstream, it means the transportation to customer, the waste treatment, the product end of life, and so on. So you see, all the scope have to be targeted and addressed. So further CO2 emission decrease, in fact, it's a real challenge. The direct emission by the glass industry already decreased by roughly 30–40% between 1999 and 2020. It means the last 30 years. It has been possible due to the replacement by from the heavy fuel by gas, natural gas, and also the improve the furnace efficiency. Be honest, it was more driven by economic reason to decrease the cost of melting glass. But anyway, it has been done, you see. So what we did in 30 years, so decreased by 30%, no, we have committed to do it in less than 10 years. So it's really challenging because the most easy part have been done. Okay? So another point also is the heterogeneity of the progress toward CO2 neutrality. The progress to reduce carbon emission is not linear over time. It's occur in different steps. It can be different from one plant to another. It can be different from one company to another, and even from one plant from the same company than another. It's due to local opportunity. Of course, you understand that the coal repair of furnace are very important, and it arrives only every 15 years, 20 years. So it means the main upgrade of furnace will be done only at this moment. So it gives non-linearity in the change. Also, the possibility to use electricity grid and the availability of green electricity is also limiting, and it's different from one place to another. And the good quality cullet is also important. If we want to use more cullet, we need to have it at the right place. I think yesterday there is a nice presentation about this point. So I'm not changed my slide since yesterday. We arrive at the same conclusion. So as a consequence, we really need a holistic approach, and it will be a combination over the time of different opportunistic situation, and of course we have to consider the Pareto approach. So what we propose and to do. First, we don't want to rely only on the cullet. Of course, people think, okay, we put more cullet, let's say close of 100%, it will be full recycled material. We decide for different reasons, I will explain, to not have only cullet, but to rely on 6 different pillars. You saw about the raw material, about the furnace, about the cullet, of course, and it will be a very important part, but also green energy, transportation, optimization. So let's go point per point. First, you can see that the 6 pillars address the 3 different scopes, because it's not reasonable to improve the scope 1 and pass to the electricity, but at this moment we will put everything in the scope 2. As we consider the total pie, we cannot move one from the other. So we really have an holistic approach, and it is one of the reasons to have this holistic approach. So first was about the raw material. So a significant percentage of the glass is made with virgin raw material at this moment. So it's important to optimize the sourcing of this raw material. We estimate that more than 25% of the total CO2 footprint of the furnace and the melting of the glass is due to the extraction and production of the raw material. So the first topic is about the soda ash. It's the first material in terms of CO2 impact, not the biggest volume, but we select low carbon soda ash because the soda ash have highest carbon contributor in the raw material. When it says low carbon soda ash, I mean the treatment, the production of soda ash, the extraction, the transportation, and so on. The second is about the sand. It's the first material in terms of volume, normally at this moment, but we take care as we not put only cullet, we still have some sand. So we use only local sand. We recommend to make minimal treatment, just what is needed to go in the furnace, not too much treatment, not too much refining, we just what is needed. And we transport this raw material mainly by barge or by a truck with biodiesel. The optimized furnace, so first we use top-class energy furnace, so it means incremental from long time. At each cool repart, we have improved our furnace by improving the design, the shape, the pavement, the pavement of the furnace, insulation, and so on. Also, we introduce and we use more and more electro-boosting. We've used several megawatt per furnace of electro-boosting. So why to use electro-boosting is not a new technology. It's to put some anodes in the melting bath and to pass electricity between the anode. The first reason is to reduce the emission, to be less dependent from the gas, natural gas, but also to have a better efficiency use of the energy. Because when we use electricity, the energy is directly bring inside the raw matter, the melting, the glass melting, and the efficiency of transmission of the energy is much, much better than with radiant fire and the gas. Sorry. One important point, why not to pass fully at electro-boosting? There is different negative impact. One is the quality. For sure, the quality, there is a negative impact of the electro-boosting on the quality, generate a lot of bubbles, and there is also some risk of local overheating. When you decrease the quality of glass, it means you melt raw material to finally produce glass with defect that you will reject. So finally, the balance, the CO2 balance is influenced, and it's badly influenced. So we have always to consider this quality aspect. So the third is the cullet. As I say, it is the most efficient way to decrease the embodied CO2. Okay, different figure exists, but always are in the same order of magnitude. And 1 ton of cullet more in the furnace, we save 700 kilo of CO2. Why? It's because it lowers the energy to melt the raw material, but also it replaces virgin raw material by a material that is already decarbonated. So normally when you add some soda ash, dolomite, milestone, all this raw material, when it's melt, it emits some CO2, and you have the chemistry equation there. And of course, it limits the impact due to the production of this material that we not put inside the furnace. But there is two major drawbacks. The limit availability of the cullet. So we discussed in different presentation yesterday. And it increased the quality risk also. If we have too much impurities in the cullet, I explained, it have an impact on the yield, and finally, it have a bad impact on the CO2 balance. So typically, we use 50% of the total volume in the furnace is cullet. 50% is a minimum. We go to 60, 65, it depends the thickness of the glass. Of course, internal cullet, no real quality issue. we use more and more pre-consumer cullet. It means it's glass that is coming from our subsidiaries. So it's typically the cutting losses when you make windows from Jumbo and so on, from AGC, but also from our customer, and we collect all this glass. The post-consumer cullet is the glass that have been put into double glazing on a building, and it come after several years back. This part, it's have more quality concern, and it's a real challenge to control it, to clean it, and so on. At this moment, be honest, we not use so much of this part. So we use also renewable green electricity generation on site in the plant. So we have a cogeneration plant, electricity plus heat. Also photovoltaic production on roof on each of our plants. We have even one windmill internal of AGC. We have also add some Rankine cycle generator to use also all the fatal heat of the process. And if we have not enough, we purchase green electricity and renewable electricity. We have signed a major contract with an electricity supplier using, they provide us electricity from 1 mile. And finally, the transport optimization. The transport optimization between our furnace to the transformation, it means coating, lamination, and so on, but also to our customer. To do this, we use integrated plant. It means plant where you have the furnace, but also the lamination operation and the coating operation. So let's see the result. We have applied this holistic approach in 2 of our plants, in Moustier starting in November last year, and in Saint-Beuve in France in May. I put the map to show it's in the middle of a dense population area where we can have all the raw material and where we can deliver with not too long distance the finished product to the customer. Again, we speak yesterday about the population and the place where to use the cullet. You see here the Moustier plant in Belgium with the Sambre River. We use it with barge to bring raw materials to the plant. As a result, we produce during the first production, but we do other production after, 3,500 tons of low carbon glass. This low carbon glass shows 7 kilos of CO2 equivalent per square meter, 4 millimeter clear float, versus 12.7 for our European value. So it's a reduction by more than 40%. What is important, it is the same glass with the same aesthetic, the same light transmission, the same haze, it's exactly the same glass. And also, we take care to have no impact on the CO2 footprint of the other production. Because, of course, we can put all the cullet we have, we can put all the green electricity we have, and then we decrease the quality in terms of CO2 emission of all other production. Here, what we do for the low carbon, it is in addition. Okay? And just to give order of magnitude, just this first production is the equivalent almost of 19 million kilometers by a standard normal car, not an electric one, a normal diesel car. So transforming the product, because of course we not put float on facade, on building, on windows, and so on. We put low-E coating, we put solar, we use solar, we put laminated glass, and finally we use also IGU, TGU, double glazing, and so on. So we have a look on all the process, all this process. You see different value. It's a range value because there are a lot of difference between a small or large lamination line, a small IGU line or a large lamination one. Anyway, you can see the pie with the CO2 origin, CO2 footprint, and you can see that the raw material is the blue part. It's the most important for all the transform. The raw material include the cutting loss, because of course we take the jumbo, but we cut to make windows, and a part will be lost, but this part have some CO2 embedded and have to be reported in the square meter per square meter of final product. We have to do it honestly, not just to count what is on the windows, but all the process from the beginning. The second is the energy, and the third is all the other. In case of double glazing, it's the sealant, it's the frame, and things like this. So the main contributor are the raw material, and ECL, I have explained. The energy used in processing operation, it means the energy used for the coater, for the laminator, for the autoclave of lamination, and so on. And finally, the CO2, for the case of the laminated glass, the CO2 embedded into the PVB, the interlayer. So for the laminated, the PVB in itself represents around 10-15% of the total of the laminated. But when you use float, low carbon float with decreased CO2 embedded, of course the part due to the interlayer of a laminated glass start to grow and can reach 25%. So the use of a PVB interlayer or other interlayer, but with lower carbon embedded, can be interesting. So to produce transform product, we apply all this. So we manage the geometrical cutting yield, renewable electricity for the energy, on-site production near the float, as I explained, and the use of PVB have not been considered in this study at this moment because we have not yet identified which one to use, but for sure it's important and it will be in the future. So this is the result. The clear light is the normal clear float, so we reduce by more than 40% as announced. The Stratobel is the laminated 442. You see what happened. The E+, it's the low E. The stop revision is a solar control, and the Thermobel is a double glazing with solar control in it. You see, we keep the target of more than 40%. Only the laminated, and I explain why with the interlayer, it's a little bit lower than the other. And to finish and conclude, some example where we have already used this low carbon glass, so different building and project under construction. We are just delivering this glass in Italy, in Netherlands, in Belgium. So we have this glass, we produce now regularly, we make already a production in Moustier, now in Saint-Beuve, we will redo in Moustier, and we continue like this. It's forecasted to enlarge to a third furnace in the future, but you have understood that it depends on the time frame. So, to conclude, I have shown is it really possible to decrease by 40% at least the float production. The fact that a holistic approach is for us very important, not focus only on the cullet. There is a really holistic approach. Low carbon transform glass is also important, especially for double, triple glazing, laminated, and so on. And it's possible to go further by improving the cutting yields, and we can think to jumbo with different dimension or things like this. And also at the level of laminated to go deeper about the interlayer low carbon. So, thanks for your attention. The glass is in the stock and is available.